In this video, we're going to talk about section 7.1, periodic functions. So consider the world's largest Ferris wheel, which is called the London Eye. It has a platform that's 50 feet tall that you have to climb up just to get on it. It has a diameter of 400 feet, and it takes 30 minutes to complete one revolution. So there's a picture of that over there on the right. So the h of t, we're going to make a function. H of t is the height above the platform in feet t minutes after boarding. So let's kind of work our way backwards and get selective points here. Since the diameter is 400 feet, and we're going to say at time 0, we are at 0. So that's 0 feet above the platform. We're not counting the platform. So it's not our height actually above the ground. It's just our height above the platform. So we know that after 15 minutes, we'll be up at the highest point. And so that's going to be 400 feet above the ground. And that means halfway between 0 and 15 minutes would be 7.5 minutes. We're going to be at that kind of 3 o'clock position. So our height would be half of the diameter, or 200 feet above the ground. Then another 7.5 minutes after 15 minutes, we'll be back to that 9 o'clock position. So we'll be 200 feet above the platform. And at 30 minutes, we're going to be right back where we were to start with. And now you can see we're going to repeat it. So as we go on our second revolution around on this Ferris wheel, then our height is going to go up to 200, all the way up to our highest point of 400, back to 200, and then back to 0 again. So let's move this over and see if we can, we're going to plot some points here. So we know we have 0, 0, and at 7.5 we're at 200, and at 15 we're at 400, and 22.5 back to 200, to 0, to 200, to 400, to 200, to 0. Now you can see that this repeats itself over and over again. So every horizontal distance of 30, which represents in our case every 30 minutes, we get back to the place we were before. So that's what we mean by periodic, is that it repeats itself over and over again. And we'll get a definition here in a little bit. So the next question then is, do we connect these with straight lines or not? And so let's see if we can make an argument why this is really going to be a curve and not going to be a straight line. So let's imagine here's our circle again, and we're going to kind of look at this distance here. So we know that we're starting out at a distance of 0 above the platform, and by the time we get to that 3 o'clock position, which we said would be 7.5 minutes, we'd be 200 feet. So if we look at that kind of halfway place there, then if we make this into a right triangle, then I'm going to redraw that right triangle over here. Now this would be 90 degrees, so that means each of these angles is 45 degrees. That means this angle in our right triangle here is 45 degrees, which makes this into our 45, 45, 90 triangle, which we know about. Now this distance, the hypotenuse, is a radius of that circle, so that must be 200. We know that in 45, 45, 90, the side lengths go x, x, and x square root of 2. So since x square root of 2 is equal to 200, x is 200 divided by the square root of 2. And if you do that division, you will get 141.4 approximately. That's rounded, 141.4. So what that's saying is that this distance right here is 141.4, which means that this distance from the ground up to that point right there, where we are at, halfway between 0 and 7.5 minutes at 3.75 minutes, this distance that I put in the red is 200 minus 141.1, which is 58.6. So you can see we, in that 3.75 minutes here, we've only gained a height of 58.6, whereas in that next 3.75 minutes here, we've gained a height of 141.1. So that's the argument that this is not going to be straight lines. In fact, we're going to be increasing but slowly at first and then faster and faster. So it's going to be concave up, and then it's going to change concavity. It'll continue to increase but slowly. It will decrease slowly at first, and then go faster and faster. So, and then it's going to repeat itself over and over again. So we're going to get this thing that is curved. Kind of looks like, I don't know, maybe like the profile of a bell or something like that, each of those kind of loops. But it's periodic, so, even though I'm not going to mark the rest of the tick marks on the X, it will continue on and on forever this way. So there is our graph, and that's what a periodic function looks like. It repeats itself over and over again. So sliding down here to the red, we can see that our definition, function is periodic with period p if f of x plus p is equal to f of x for all x. And the smallest p is the fundamental period of f. So for our function h, the period, that horizontal distance that you travel and before you start repeating yourself, is 30 minutes. Now, that's the fundamental period because that's the smallest distance you can travel before you repeat yourself for all values of x. It would be correct also to say, you could say a period of f would be, say, 60 minutes, because this thing does repeat itself every 60 minutes as well. But the fundamental period, the smallest distance you can travel where you repeat yourself, is going to be the 30 minutes. And that's generally what we're looking for, is that fundamental period. Now we also have this idea of what's called an amplitude. So in this periodic function, we can see that there is a largest y value and a smallest y value. So one way to define or describe the amplitude is to take the maximum value, which in our case was the 400, minus the smallest value, which in our case was 0, and then divide that by 2. And so for us, the amplitude of our function, of our periodic function h, is 200. Another way of describing or defining an amplitude is it's the distance, which means it's always going to be non-negative. So an amplitude is always going to be positive. It's the distance from the midline to the peak. Now what we mean by the midline is down here, that's that line that goes halfway between the maximum and minimum. I'm going to scroll back up here. So this is the midline of our periodic function, that line that kind of cuts the graph in half. So our midline was that line y equals 200. So that's our midline, is y equals 200 for h of t. Okay, with these definitions of period, amplitude, and midline, let's look at a new periodic function. So here we have one drawn, and looking at that, can you see that the period, that fundamental period, that shortest distance that you travel before it repeats itself over and over again, is going to be 4. The amplitude, which is the maximum value minus the minimum value divided by 2, that's 2 minus 0 divided by 2 is going to be 1, so the amplitude is 1. The midline is going to be that line that goes through the middle of our graph. That's going to be y equals 1. And now some kind of interesting questions using this idea of a periodic function to predict what that value of the function is far away from what we can actually see on the graph. So what we mean by periodic with a period of 4 is it's going to repeat itself every horizontal distance of 4. So if we start at 0 and we go a distance of 4, what we see continuing from 4 on looks just like what we get continuing on from the origin. So in a sense, we can think of it as kind of almost taking us back to the origin. So if you take 200 and divide it by 4, and we're looking really for the remainder. This goes in there 50 times, but the remainder is 0. Since it goes in there evenly, at 200, we are going to be at a multiple of 4. That is, it's going to look like we're right at the origin. And so if we were at the origin, then the y value, f of that value, would be 0, and that's going to be the same for 200. Now at 401, if you divide that by 4 and take the remainder would be 1. So 4 times 100 is 400. That goes in there evenly. The remainder is 1. So that when you are at 401, it's going to be like you are 1 to the right of being at the origin. And the y value there is going to be 2. And so that's how we know that f of 401 will be 2. Now we can continue this in the negative direction as well. So going negative 10 means we're going to go negative 4, negative 8 will take us right back to like we're at the origin, which will also look like we're right here. If we continue another 2 to the left, that's going to take us to a y value that is also 2. All right, hope that makes sense.